Hi, everybody. Welcome to my continuing series on basement mathematics. We are starting a new chapter, which is all about, well, it's mostly about volume of different three-dimensional shapes, but we're going to deal a little bit with triangles, area, and perimeter of the regular stuff, just to get you remembering the skills that you had out of grade 8 and get those triangle juices flowing. So we're going to start with the Pythagorean theorem. The Pythagorean theorem is used to calculate the length of an unknown side in a right triangle. Now, what is a right triangle? It's a triangle that has one angle equal to 90 degrees. Okay, so that little square means 90 degrees. And without that 90-degree angle, you can't do nothing, all right? The hypotenuse will just fall off. Now, the side opposite to the right angle is called the hypotenuse, and it is always the longest side in a triangle. So the Pythagorean theorem, usually it's a squared equals b squared. A squared plus b squared equals c squared. For some reason, we're doing this backwards. C is always the longest side. So once again, it's across from the 90. A or B, A or B. Now, some math teachers will tell you it's very important that one side is A and one side is B, and those people are wrong, okay? Next year, when you get into grade 10, there is specific names for specific sides, and they have specific meanings. For the Pythagorean theorem, it really doesn't make a difference, okay? Mathematically, it doesn't matter. And while you could say, I don't know, the short side is A and the long side is B, at the end of the day, it doesn't make a difference. So I'm not going to get fussy about it. So we use A and B to represent the shorter sides and C to represent the longer side. Okay, so hopefully you remember all this, but as always, if you need to, hit your pause button in order to try and answer the questions yourself before I answer them. Which side of each triangle is the hypotenuse? And it is these sides because they are across from the 90. Yeah. Calculate the length of the hypotenuse of each triangle. So here we got to do a little bit of math. And some of you have probably been taught the different ways to solve for, oh, actually that's not in this part. You'll hear me do all that spiel in just a second. So we'll focus on what we got because it does not apply here. And notice I'm putting my units in on the last lesson. Now notice there's nothing there. It's okay if there's no change. I had a discussion with my grade 10s regarding that, and they seem to think that you always had to write it out, and it is not true. If there is no change, then you actually don't have to write that side out again. It doesn't make a whole lot of sense. If it hasn't changed, then why are you doing it again? You're just running the risk of making a mistake. Now, here's where I started to say, some of you have been taught the isolated versions. No, no, no. That's bad on your teachers, and you guys need to get out of that habit. Okay, we've gone through our algebra. We should be able to manipulate the Pythagorean theorem the way it's written. Notice, this is the side across, it's the longest side, so it's C. You don't move the variables around to make it easy to solve. You put the variables in where they're supposed to go and then solve. Oops. Oh, forgot my units. There we go. Notice my algebra, I'm just doing it. I am not showing the steps for how I got it. I'm just making it happen. If you're not quite at this point with your algebra, then work towards it. Okay. Ideally, your skills get better enough that you don't need to show all the work. Showing the steps actually doubles the amount of work that you're doing. And let's face it, algebra is hard enough without having to figure that out. So in order to find the area, let's get rid of that. Started doing something else and I don't need that, yay. But we don't know what the b is, right? That's this value here. So we need to solve for that. Now, why am I working to so many decimal places? The answer is twofold. First, when we get into when we get into trigonometry next year, I'm going to expect you to work to 4 decimal places. But the other thing is that the more decimal places you have, the more accurate your answer is going to be. And at 4 decimal places, pretty much everything works out to what it's supposed to be, like as an exact number. So it's a good habit to get into, and I'm going to stress that you do this year. What's 69 minus? Oh, I could have done that in my head. Bad, Mr. S. Bad, Mr. S. You will not lose marks for this. However, if the final answer is supposed to be 1 decimal place, you will lose marks if you aren't working to at least 2 decimal places. And I will be emphasizing that as we go through. Okay. Well, I do have another example in here. What is the height of a 12-inch screen computer if its width is 8? So height Let me just do this. Ah, we did just do that. Look at that. Oh, except that's 12. I'm reading the wrong one. Sorry, guys. I was humming along so quickly, too. That makes that 80. Square root of 80 is 8.9 inches. So it's 8.9 inches high. And 120. And pictures are your friends. Don't be afraid to draw a picture. So if he's traveling 200 meters across the diagonal, 160 plus 120 minus 200 equals, what is that? 280 minus 200, 80 meters. Okay, guys, like I said, nothing new today. Hopefully this was all review and you're all going, yeah, I knew that. And that was the whole point, was just to remind you of what you already knew and just how smart you are. Okay, guys, go have fun.